So, good day sir, and good day co-cadet. So today we're going to discuss or report our topic, which is the marine compass, magnetic variation, and correcting for variation. So first we have the course. So our course is the Mtec 102 or the Enhancement for Maritime course. Period, we are now in midterm. Week, this is the week 1 for midterm, and this is the first session or the session 1. So we are the group 1 and the members are namely, so yours truly, I'm the Cadet Abad together with my colleague, the Cadet Abajo, the Cadet Abali, and lastly the Cadet Tangkay. So for the course outcome, so the students should be able to know the history of magnetic compass, magnetic variation, and how to correct a variation using the compass rose. Learning outcome. So at the end of this lesson, the student should know how to correct a variation from the true north, magnetic north, and compass north based on a given correction in the compass rose. So the importance of the topic. So to the future seafarer, it is very important that we're going to discuss this topic so that we can gain a sufficient knowledge once we go on board. And it also serves as a preparation and training on how to correct a variation as part of our job. So, but before we jump to the proper discussion, first we must define what is marine compass and magnetic variation. So, marine compass, so it is a large magnetic compass used on board ships consisting of a compass card suspended in a gimbal mounted bowl, or it is a compass that is used in navigation that consists of parallel magnetic needles or a bundle of needles permanently attached to a card that is marked to indicate direction and degrees of a circle, while the magnetic variation is the angular difference between the true north and magnetic north at a particular place, or the horizontal angle between true north and magnetic north measured east to west according to whether magnetic north lies east or west of the north. So now I will give the floor to my colleague to discuss the marine compass, magnetic variation, and correction for variation.
In China, compasses have been used since the Han Dynasty, when they were referred to as south pointers. At this time, naturally a magnetized iron ore or magnetite, also referred to as iodostone, seems to have been initially discovered in what is now modern China. The iodostone spoon is placed in the center of a bronze plaque, and the magnetic properties made it spin around. When it stopped, the handle of the spoon would point to the south, and the ball part of the spoon would point north, and these compasses were called as the south pointers. However, at first, these magnets were only employed for geomancy like feng shui because of how the iodostone would have been seen as possessing magical properties, and hence these compasses functioned as tools of geomancy used to foretell the future. Eventually, during the Song Dynasty, many trading ships were then able to sail as far as Saudi Arabia, applying compasses for actual marine navigation. As a direct result, between 1405 and 1433, Emperor Chudi's treasure fleet of the Dragon Throne ruled the entire South Pacific and the Indian Ocean. At this time, Western mariners were still rather incognizant of the navigational application of the magnet. The first treatise on the magnet itself was written by Petrus Peregrinus de Marker de Magnet on 1269. In his Epistola de Magnet, he describes the iodostone and its magnetic properties, the two poles of a magnet, and the fundamental properties of magnetic attraction and repulsion. He proved that unlike poles attract, while like poles repel. He also established by experiments that every fragment of an iodostone, however small, is a complete magnet, and determined the position of an object by its magnetic bearing. And though its nautical use was already mentioned in 1187 by the English monk Alexander Neckham, The use on board only came about around the 13th and 14th century of the Mediterranean Sea. In 1545, Pedro de Medina wrote the Spanish standard work Arte de Navegar, or Art of Navigation, on marine compass navigation. Arte was the first treatise on navigation to be published in Spain. This masterpiece was first translated to Dutch in 1580s and was put into practice by Jacob van Heemskerk when the Dutch destroyed the Spanish fleet near Gibraltar in 1607. A drawback, obviously, it was van Heemskerk's own death during this victory.
Next is magnetic variation. As we all know that magnetic variation or magnetic declination is the angle on the horizontal plane between magnetic north and true north. As we say magnetic north, the direction, the north end of a magnetized compass needle points corresponding to the direction of the Earth's magnetic field lines. As we say true north, the direction along a meridian towards the geographic North Pole. In the fin de siècle, or the end of century of the 16th century, mariners believed that the magnetic North Pole coincided with the geographic North Pole. Any suggestion otherwise had been denied by Pedro de Medina. As we all know that Pedro de Medina was a Spanish cartographer, or a person who draws or produces maps, and author of navigational texts. Magnetic observations made by explorers in subsequent decades showed, however, that these suggestions were true. But it took until the early 19th century to pinpoint the magnetic North Pole somewhere in Arctic Canada on 78 degrees north, 104 degrees west. From then on, the angle between the true north and magnetic north could be precisely corrected for. This correction angle is called magnetic variation or magnetic declination. It is believed that the Earth's magnetic field is produced by electrical currents that originate in the hot, liquid outer core of the rotating Earth. The flow of electric currents in this core is continually changing, so the magnetic field produced by those currents also changes. This means that at the surface of the Earth, both the strength and direction of magnetic field will vary over the years. This gradual change is called secular variation of the magnetic field. As we all know that secular variation describes continuous drift in the intensity of and direction of the Earth's magnetic field. Therefore, the encountered magnetic variation not only changes when location, but also varies over time. The correction of magnetic variation for your location is shown on the nearest nautical charge compass rose. As we all know that compass rose appears as two rings and one smaller and set inside the other. The outside ring denotes the true direction and the smaller inside ring represents magnetic directions. In this example, we find variation of 4 degrees 15 minutes west in 2009, with an indicated annual correction of 0 degrees 8 minutes east. Hence, in 2011, this variation is estimated to be 3 degrees 59 minutes, almost 4 degrees west. And for 2020, the estimate is 2 degrees 47 minutes west. This means that if we sail 90 degrees on the chart, the true course, the steering compass would read 94 degrees in 2009 and almost 93 degrees in 2020. Note that the true course is often shown as COG, or course over ground, or CNG, course made good on your GPS plotter. Another example, let's say the compass rose on the nautical chart gives the variation of 2 degrees and 50 minutes east in 2019, with a correction of 0 degrees 4 minutes east per year. In 2021, this variation is estimated to be 2 degrees 58 minutes, nearly 3 degrees east. If we sail 90 degrees on the chart, the steering compass would read 87 degrees. A paper on digitized nautical chart can feature multiple compass roses. Use the nearest one to obtain the magnetic variation.
Thank you, co-cadet. So next, I will be discussing the correcting for variation. So the overlaid compass roses on the right illustrate the difference between true north and magnetic north, when the magnetic variation or the VAR is 10 degrees west. So from the image we find, TC is equals to, or the true course is equals to CC, the compass course, plus the variation, in which the CC and TC stands for compass course and true course, respectively. So to convert a true course into a compass course, we need first assign to a western and to an eastern variation. Note that this makes sense because of the clockwise direction of the compass rose. Here, the inner circle is turned 10 degrees anti-clockwise. Hence, it is negative or minus 10 degrees. Now we use the same but rewritten equation. CC is equals to TC minus VAR, or compass course is equals to true course minus VAR. So since the formula of getting the compass course is true course minus variation, but we have a sign of negative for the variation, and the operation of the formula is minus, so therefore the operation will become addition. So 225 degrees less the true course plus the variation, which is 10 degrees, we can get the value of compass course of 235 degrees. So to sail a true course of 225 degrees, the helmsman has to steer a compass course of 235 degrees. So to convert a compass course into a true course, we can use the original equation. If we have steered a compass course of 200, we have to plot a true course of 203 degrees in the chart if the variation is 3 degrees east, or a true course of 190 if the variation is 10 degrees east. In addition, I will be giving another example in correcting for variation. So here's the example. In a chart, the compass rose showed a magnetic variation of 5 degrees east and compass course of 65 degrees. How will you convert that compass course into true course in order to perform also the correcting for variation? Since the assigned magnetic variation 5 degrees is an eastern variation, opposite to the first example, that means it is a positive or plus 5 degrees. Therefore, we will be using this formula, the original formula. True course or TC is equals to compass course CC plus the variation. TC stands for true course, CC stands for compass course, and VAR stands for the magnetic variation. And this would be the solution. So TC, here's the formula. TC is equals to CC plus the VAR, or the variation. So we have the compass course of 65 degrees and the variation of 5 degrees. So these two will be added, and we can get the value of true course, which is 70 degrees. So there's a note: in order for the OOW or the helmsman to sail a true course of 70 degrees, the helmsman shall be steering a compass course of 65 degrees. That's all. Thank you.